So yes, we are starting our unit on quadratics. What makes a quadratic a quadratic? Mm-hmm. What in an equation makes a quadratic a quadratic? An exponent of what? 2. Yes. Quadratic equations have the x squared. So here, I know it didn't print out very well. It printed out as these little boxes. What do you think the parent graph, the parent function is going to be? Y equals x squared. Beautiful. Y equals x squared. So now we're going to graph this without looking at our calculator. Where do you think the first perfect point is? Yeah, 0, 0, the origin. This is also called the what of our graph? The vertex. So our vertex is located at 0, 0. Highest or lowest? It's going to be our lowest point. Mm-hmm. Min or max. Mm-hmm. On a quadratic. All right. So where is my next perfect point? How do you know 1, 1? So here, if I put in a value of 1 for x in my equation, what is 1 squared? 1. So if x is 1, y is 1. My next perfect point is 1, 1. And on the other side, what can I now graph? Negative 1, 1. A quadratic is a perfect mirror. It is very, what is that called? What is that word? Symmetrical. It is perfectly symmetrical. What about if I have an x value of 2? 4. So if I have an x value of 2, what is 2 squared? 4. So the next perfect point is going to be at 2, 4. Well, so and same thing on the other side, negative 2, 4. And then what about when x is 3? 3 squared is 9. And then I'm going to connect my points. Now, this, as is without my line, looks extremely like what function did we just go over? Last unit. What was 2 units ago, sorry. Absolute value. Do I want you to see, or do I want to see that for this? No. And at last class, I already saw a couple people drawing a V. This is no longer an absolute value. It is a quadratic. It is curved. I don't want a sharp point at that bottom. This is the parent graph, y equals x squared. Is the vertex a maximum or a minimum? Why is it a minimum? It's the lowest point. Perfect. We'll do x and y-intercept first. What is my x-intercept? 0, 0. And my y-intercept? Yeah. Now, let's recall. Set notation. Set notation is which type of notation? Right. It's the long one. It's the set builder. You're building something long. So you start off with a squiggly bracket. Then what? Right, what variable? X is in all real numbers. Then? And you look for your least x value. What is my least x value here? I never stop going down. I never stop. It keeps on going up and to the left infinitely. So my lowest point is negative infinity. What is my highest x value? Positive infinity. So, do I even really need that symbol? Nope, I can just end it like this. X is all real numbers. Or it wouldn't be wrong if you put this. I wouldn't mark it wrong. It just means you like to write because it's not needed. Now let's do range in interval notation. What is interval notation? With brackets and parentheses. Perfect. So what is my, well, first, whoa. What value do I put first? My least value. On the test, for that reasonable domain problem with the garden, I saw a lot of this. I saw at least 4 people put this. What is wrong with this? Right. Negative infinity is the lowest possible value you could ever have. Your lowest value should always go where? On the left, right? Just like a number line. All your low values are on the left. All your highest values are on your right. If you put this, it tells me that something conceptually is very, very wrong in your head with math. Remember, lowest value left. Lowest value left. This should never be over here, ever. Sorry, it was just like I could not believe I saw that. Range. What is our least value on this y-axis? Is it touching 0? So what do I put? Bracket. And 0. And then what is my highest y value? It keeps on going up forever, so it's infinite. And what do I put? Parenthesis or bracket? Right, because you can never actually touch. You can never actually be infinity. Any questions on our parent graph? Pretty straightforward, right? All right. Now, we're going to go over this thing. Does this look familiar to you? It should. Where does it look familiar from? Oh, way back, like the very first instructional day we did this. This looks extremely similar to the parent function transformation equation I gave you for absolute value. What's the only difference? Right. So instead of my absolute value lines, I now have parentheses and also what else? It's squared. That square is what makes this a quadratic, right? Just like the lines are what made an absolute value an absolute value. So anytime you see the x is squared, it's quadratic. All right. Even though the absolute value has now been changed out for a square, it still works the exact same way. So, A. What transformation was A in absolute value? It was your vertical transformations. Vertical. When A was less than 1, so when the absolute value of A was less than 1, it was a vertical what? So less than 1 means it's a fraction. So say 1/2. It would be a vertical blank by 1/2. Compression by 1/2. When A is greater than 1, what is it? Now it's a vertical stretch. Why am I putting absolute values on these A's? What else have we not talked about that could also be vertical?
Horizontal compression.
Well, yes, that's going to be next. But something else that still could be in front of A. Oh, does the negative change the stretch or compression? That's why it's absolute value, because the negative makes it what? Good. Reflection. It makes it reflect. Over which axis, by the way? Over your x-axis, yes. It's vertical. And B. Now we get on to B. What was B, did we say? Horizontal. And what's special about our horizontal transformations? It's inside the parentheses, meaning what? It's opposite. It's opposite from what you think. So it's opposite from vertical. So if the absolute value of B is less than 1, it's a what? Stretch. Horizontal stretch. And if B is greater than 1, it means what? Compression. That being said, if I had a B value of 1/2, tell me what it is. It is a horizontal stretch by how much? So I said 1/2, so it's a horizontal stretch by 2. By 2. Remember, you take the reciprocal. So if it had been 2, a B value of 2, it'd be a horizontal compression by 1/2. Okay? It's backwards. And also, negative B is a reflection over the Y. Now, that being said, can you ever tell a horizontal reflection in a quadratic?
When it's graph?
Yes. No, right? Because it's perfectly symmetrical, you don't have any idea if it has been reflected. So we're really not going to be dealing with the horizontal reflection in this unit. Later on, when we get to non-symmetrical functions, yes, we can see the horizontal reflection. Go to lunch. So we got the hard parts completed. Now just for the H and K. H and K represent what? What type of transformations are those? They are our translations. Good. So here, I'm going to write translation. Now, H. The H makes the function move how? To the right or left. If H is negative, where does it go? To the right. Yes, it's still inside the parentheses, so it's backwards from what you would think. And if H is positive, where does it go? To the left. Perfect. If K is negative, what happens?
It goes down.
It goes down. It's normal now. And if K is positive, where does it go? Up. Perfect. Is any of this new information? No. And in fact, all of the functions that we're going to learn in this school year have the exact same transformations, normally in the exact same places. So this is not going away, these transformations, which is great because it's easy. All right. Any more questions on this? Okay. I want you to try to complete this example 1 on the back. I'm going to give you guys about 10 minutes or so, and then we'll go over it. So, what do you think we should do first here? The equation or the rest of it? I would do the rest first because all of this info below the equation is going to help you write the equation, right? So looking at this graph, interval notation is which notation? Bracket and parentheses, good. So what is my lowest x value? And negative infinity. And what's my max x value? Positive infinity, good. Oh, well, that works. And my range. What is my least y value? Right. So I'm looking when do I stop going down? I never do. So it's negative infinity. And what's my max, my highest y value? Positive 1. Am I touching the value of 1? Yes. Yes, I am. So it should be 1 what? Bracket. 1 bracket. Because I am touching 1. And where's my vertex? Negative 2, 1. And where is my line of symmetry? And where did you get that from? What is the line of symmetry? Very good. It is the middle of your function, is where, if you folded this graph along this line, the sides of your function would line up perfectly. So this here is my line of symmetry. It passes through which axis? The x. So I know it's going to be x equals. And at what value does it pass through? Boom, that's my line of symmetry. And is my vertex a max or a min? It is a maximum, right? It's the max point on the graph. Where is my y-intercept? 0, negative 3. Now, sometimes you are going to have graphs where it's not a perfect y-intercept, right? It's maybe, if I were to draw a line like that. Is that going through a perfect point there? No. How can you figure out what y is? What can you do to find the y value? That's okay. Okay. Thank you. What can you do? Easier. Without a calculator. At our y-intercept, what is the x value always? 0. So going back to our equation, once we find it, what can I do to it to find the y value when x is 0? So, okay, say I had this. What is my, just looking at this, what is my y-intercept? 4. And how could you have gotten that? Why is it 4? Because it's plus. Okay. What is the x value at our y-intercept? 0. So what you're literally doing is putting 0 in for x. Your y-intercept is 4. Anytime you don't know the exact value, all you have to do is plug in 0 for x, and you can find your y-intercept. So here it was really easy because I went through a perfect point. It was negative 3. Oh, sorry. 0, negative 3. What about x-intercept? Perfect. Negative 1, 0, and negative 3, 0. What is another word for our x-intercepts? The zeros. Or also they are called your solutions. They are also called the solutions to the function. Who knows if they aren't perfect points like we see here on the graph, who knows how you find the x-intercepts? Okay, so say I plug in 0 for y. How do you solve that? In Algebra 1. Let's do this. How do you solve that? What are my like terms? It is in the right order.
I thought that was just in a thing. I didn't realize that was.
Oh, okay, yeah, this is the next one.
You have to read it.
So you get everything on one side and divide by 2 and then square root this. Can I square root this? I can, but will it get me closer to an answer? Somebody's got to remember what you do to solve this. Yes. Oh my God. You have to factor. So that's what most of this unit is about, factoring. We're not doing it today. You have a reprieve. But starting next class, we're going to start to do things like factor. So, lastly, on this graph, what are our transformations? Where did I go? Right, I translated up 1 and left 2. I also vertically reflected. Anything else? How can you tell that I didn't stretch or compress? Right, so my next perfect point was just up 1 over 1. All right, I want to do the next one. Oh, wait, whoa, we have to do the equation. Oh my gosh. So how do I start off my equation? Right. Fx equals negative, then what? Parentheses. X, and then we went to the left 2, so plus 2, and then parentheses. And then we went up 1. Done. And what form is this equation in that we just wrote? Vertex form. This is vertex form. Any questions on this one? All right.